Okay, so they're going to talk about one-to-one and inverse functions. First off, they're going to say, hey, is this function one-to-one? And one-to-one is just what you would expect. A one-to-one function means one input, or x, for one output, or y. Just like you'd expect, you know, one-to-one. There's one thing for one thing. So what do you think about this? They're drawing it with arrow diagrams. A function is just connections between inputs and outputs, right? I could do a toaster. I could go bread and frozen waffles. And I could go connects over to toast, connects over to toasted waffles, like that. And I could say the function, this is this part, this is this part. The function is the arrows. It is the connection, and that's the toaster. The toaster is the function, right? For example, so I'm trying to connect it, make it real for you, right? So all a function is, like a toaster's a function, is something that connects inputs with outputs, right? You put in bread, you get out toast. You put in frozen waffles, you get out toasted waffles. What makes that connection from bread to toast and frozen waffles to toasted waffles happen? A toaster does. That's the function. So that's all this is. So it's just inputs, outputs. So is it one-to-one? No. These two go to that one. So no, these two are going to that same one. No. No. Easy as that. It's supposed to be one arrow to, one object to one object straight across. If it does anything other than that, it's not one-to-one. That simple. Question though, is it 1x for 1y? So look here, so let me write that bigger. So 2 goes to 9. That's an x, that's a y. Let's list them vertical. It might be easier vertical. 3 goes to 6. Negative 8 goes to 3. 6 goes to negative 8. So do you see any repeating? These are all different x's, aren't they? And they're all going to different y's. So that's a yes, that's okay. You okay with that? What would be bad is if we had 6, 2, for example. Then 6 would be going to negative 8, and 6 is also going to 2. Oh, no, can't do that. That would be a no-no, right? Or if we had like 1, 9, and 2, 9, right? Both 1 and 2 going to 9. That'd be a no-no. That'd be not one-to-one. But we don't have any repeating, so it's good. It's one-to-one. Am I going too quick? Is it making sense? So if you want to list them vertical, I think it's easier. 10, 10, 11, 11. So 10 goes to 10, 11 goes to 11. That's fine to go to your same number, whatever. 12 goes to 30, and 13 goes to... Zinni, do you ever have the same number going to two things, or vice versa, No, that's good. Yeah, one-to-one. It's fine. All right, you just don't want the same x going to two y's or the same y coming from two x's. You don't want that. Do you guys remember the test for a graph being a function? Vertical line test, right? Vertical line test. So if you have a graph, say like this one, that fails the vertical line test. Vertical line hits 2 points. It's not a function, therefore, right? Why? Because that means if you're over, you ever thought about why the vertical line test is the right one for a function? Because if you're over, like think about these two dots and what their coordinates might be. Maybe it's over 4, up 3, I have no idea. And that one's like over 4, down 3. Whatever, they're over the same amount, which means they're not one-to-one. Do you see that? When you have a vertical line hitting 2 points, that means the same x value, the same over amount, is going to two different y values, two different heights. That's why it's not one-to-one. Same thing now. So well, that means it's not a function. Now we can have functions like this, which is a function, right? It passes the vertical line test. Every vertical line only hits 1 point. But it fails the horizontal line test, which means although it's a function, it's not a one-to-one function. Right? This would be not one-to-one. Because you get these two dots at the same height. That'd be like over 5, up 3, and back 5, up 3. That'd be the same height, same y for two different x values. That would not be one-to-one. So you might look at that and go, you mean y equals x squared is not one-to-one? Right. Y equals x squared is a function, but it's not one-to-one. Right? Because look, you can put in negative 2 and positive 2, and both of them squared go with the y value 4, don't they? It's not a one-to-one function. So anyway, this picture here, is it one-to-one? They're just saying do the horizontal line test. Yeah, every horizontal line hits only 1 point. So yes, it's good. So just like the vertical line test, you want it to hit only 1 point. The horizontal line test, you want it to hit only 1 point because that means it's 1 to 1. It's got to pass both the vertical and the horizontal. They're only asking us about the horizontal because they already said it's a function. They're saying, we already know it passes the vertical. Test the horizontal. So that's what up here. See, fails the horizontal line test. No, done. That quick. Yes, no. Okay, so now it's saying here's a function, right? Function is just a connection between inputs and outputs. And this would be Carly, Bob, Jessica, Tim, and Hannah, and the points they got in some kind of game. So now, which of the following is the inverse? What does it mean? What is an inverse function? It is a switching of inputs and outputs, x's and y's. Just switch roles. That's what an inverse function is. So which one is that? Oh, I guess it's this one. They kind of look the same to me. Oh, they just mixed them up. Yeah, Carly goes with 162. 162 to Carly. So there it is. So they just, just switch them. And what's the domain of the inverse function? Domain, remember, is x values, inputs. X's. That's what, remember, range is the y values, right? Range is y values up and down on the graph. Remember that we did range? Domain is sideways, x values. So the range is the outputs, or the y values. The domain is this. So when they say, what's the domain? What's this? Domain of the inverse, anyway. Which is the range of the original. Right? You tracking with me? Am I going too quick? Right? So when you do an inverse function, domain and range switch, don't they? They're going to have us use that in a couple minutes here. So let's file that away. So the domain and range of the original function, when you go to the inverse, they switch. Because that's exactly what an inverse function is. Switching of inputs and outputs, which is a domain and range. So they're asking the inverse's domain. So here's the domain for the inverse. So it'd be B, wouldn't it? And probably the next question is what's the range, and it's that for the inverse. All right. Okay, so if you have the function listed this way, I think it's easier to list it again vertically. -4, -5, -3, -13, -2, 13. I'm just listing these. -1, 12, and 0, -12. Okay, so that's the original function. So the inverse, that's how you write inverse, -1 power. That means inverse. The inverse function is just going to switch the x's and the y's. So it becomes -5, -4, -13, -3, 13, -2, 12, -1, -12, 0. There's the inverse. So whichever one does that, is it B? Looks like B, yeah. Good. Just switch x and y's. That's an inverse function. Want to move along? You're good. Okay, so they're giving me f of x is 2x minus 1, g of x is a half, x plus 1, and they're saying, what is f of g of x? So composition again, sticking one function inside the other, right? So I'm going to say they're giving me f, they're giving me g, and they're saying, what's f of g of x? That means put g into f, doesn't it? Right to left, always right to left for these things. So put g into f. Put g into f. So here we go. Take all of g, and I'm going to put it in the x slot of f. You with me? So it's going to be 2 something minus 1, and what that something's going to be is g, which is a half x plus 1. So we good to there? So I got to clean it up. But are you good so far? See how I just stuck all of g into the insert slot, the holes in the toaster for f. Okay, now can you clean that up? What's going to happen? You see it's just going to be x. See? Whoops. There we go. So do you see that a half times 2 just cancels? And you just have x plus 1 and you get that minus 1 at the back. Is that good? 2 times a half just cancels out, it's just 1. So 1 times x plus 1 is just x plus 1 minus 1 is x. So f of g, put it together, clean it up, it's just x. What does that mean? I mean, what does that mean about f and g? You see, I just took x, I put it into g, then I put it into f, and it came back out the way it started. X again. What does that mean if you take something, you put it into one function, comes out different, put it in the other function, comes back the way it originally started? What did that second function do? The reverse of the first function, right? If it made it back the way it started, right? So if you take something, I take bread, I put it into some kind of machine, pops out, goes to the other machine, turns it back into bread. That means the second function is the inverse of the first function, or they're inverses of each other, however you want to say that. They're doing the opposite of each other because after it went through both machines, it came back the way it started. It's just x again. That proves that f and g are inverse functions. And look at them for a minute. They kind of look the opposite, don't they? 2x, multiply by 2 and subtract 1. This is multiply by a half and add 1. That's opposite, isn't it? Those are opposite machines. Those are inverse machines. We just proved it because when you plug one into the other, it just comes back with x. So when f of g just equals x, and both ways, g of f, you've got to run it through both machines, both directions. If you run through both machines, both directions, it just comes back x, this comes back the way it started. When that happens, this proves g and f are inverses. That's how you prove two functions are actually doing the opposite of each other. If you run an x through both of them and it comes back the way it started, the second one must have undone whatever the first one did, because it's back the way it started. They're inverses. So that's what they're going after on this question. So they're wanting you to plug it, run it through both, and see it just equals x. By the way, if you want to save some time, guys and gals, when you do one of them, it's x. The other one's always going to be x too. So as soon as you do one of these, it comes out x. You just go, oh, okay, the other one's x also. Boom. It's always going to be x. And now and then they ask you about the domain. They say here, give any values that need to be excluded. What does that mean? Need to be excluded. Domain. Remember, that's what domain is. What you can't put in tinfoil into the microwave. Well, does this one have any domain issues? Are there any denominators or any square roots? No. So no values are excluded. The domain's all reals. No values are excluded. Nothing is not allowed, to use a double name. Everything's allowed, right? Because there's no denominators. All right, we good? Okay, so remember the domain question we've had about square roots and you can't put negatives in square root? That's only for even roots. Odd roots don't matter. Have you thought about that? You can do the odd root of something like -8. It's fine, huh? What times itself 3 times is -8? What times itself 3 times is -8? -2 times -2 times -2 would go back to -8, wouldn't it? So the cube root of -8 is -2. So it's fine to put negatives in odd roots because an odd amount of negative things comes out negative. It's not a problem. But you can't do the 2 root of something like -9. That's not going to work. How can you have like a -3 twice become -9? No. You can't have something twice become negative. That can't work. So what's my point in that whole thing? This is imaginary. Imaginary. And this one's okay. So only worry about the 2 roots with the inside. So when we do the inside, take out the inside, and say, hey, inside, you can't be negative. That's only for 2 roots. So for odd roots, odd root, no domain problem. So this one's going to be no problems again. This one's going to be just like the last one. Odd roots don't matter. Odd roots are not a problem. It's only 2 roots that are a problem. So when you go, so I can tell you f of g of x is going to be x. I'll just write the answer in right now. It's going to just be x because those are the opposite machines of each other. You could do it formally, you would see. And then when they ask you the domain question, you'll say no problems, no restrictions. Don't even mess with that root. It's an odd root. It's got no problems. Good? See, this is actually an easy, I'm trying to get quickly through this section because 5.3 is hard and 5.4 is hard. And those are our last two sections on the test. So I want to have some time. I'm going to get there with a little bit of time to slow down. So all right, so here's a function. They want us to graph the inverse. I don't know if you ever knew it, but graphically, so now we're saying what is an inverse graphically? Graphically, an inverse is a reflection across the diagonal line. Did you know about that? So the inverse will be right over here, reflected. Let's prove it. What does an inverse function do? Inverts x and y's. So if I take negative 4, 1, for example, and switch them, it'll be 1, negative 4. Let's find that dot. Over 1, down 4. Right there, isn't it? So that's over 1, down 4. Let's take these guys and switch them. Negative 5, negative 5. Well, that's going to still be negative 5, negative 5. It'll be right there, won't it? Let's take 1, 2 and switch them. Well, it'll be 2, 1, which will be right here. 2, 1. See what's happening as I connect these guys? And 2, 3 and switch it. It'll be 3, 2. 1, 2, 3, 2 right there. 3, 2. See what it did? See when I switched all the x's and y's and connected dots? See how the image is a reflection across the diagonal line? That's the line y equals x, that diagonal line. So when you switch x and y's, which is what an invert, you invert x and y inverse function is, what you get is a reflection across the y, because y equals x is when y is the same as x. So if you switch x and y, you're going right across that equality line. That's what you're doing. So that'll be easy. So you just grab the multiple choice one that looks the same. Okay, so now they're giving me f of x is 4x, yeah. And they want me to find the inverse. Find the inverse, which they call f to the negative 1. All right, so how do you do it? How do you find it? We've done it for graphs. We've done it for like tables and x, y numbers. But how do you actually do it for a whole equation? How do you find the inverse for a whole equation? So f inverse for a 4, it's not an equation, it's a formula. For a formula, number 1, you invert, as you know, invert switch, x and y. Number 2, solve for y. That's all it takes. So invert, because inverse function means invert x and y, solve for it. Now when I say invert x and y, look up there, where's y? I don't see y. Well, you know this is y. Function values are y values. So f of x, g of x, those are y, by common agreement in the math science world. That is y. So when I say switch x and y, I literally mean y takes the place of x, and x takes the place of y. Nothing else moves. The 4 stays put, everything else stays put. All the x's magically poof become y's, and all the y's magically poof become x's. They trade roles, inputs and outputs, x's and y's. That's what an inverse function means. Invert the roles of x's and y's. Now, step 2, solve for y. So how do I solve that for y? Well, that's not a hard one. Divide by 4. Boom. So x over 4 is the inverse function. And that makes sense, right? That's the opposite of 4x, isn't it? Dividing by 4 is the opposite of multiplying by 4. That was just, they're going to get much harder than this, obviously. Just warming us up. So that's the inverse function. Good there? Inverse function. Was there any other? So now, the second part, they're going to say, okay, graph them both on the same axis system. Okay, well, you know how to graph. Let me come up here, right? You know how to graph a line. So let's start with the first one. Y equals 4x. You know how to graph y equals 4x, right? The y-intercept is 0. Start at 0. This is 4 over 1. Go up 4 over 1. There it is. So there's the y equals 4x. And now how do you graph the other one? This is y equals x over 4 plus 0. So for this one, I start at 0 as well. And I go up 1 over 4. There. Connect that one. That's y equals x over 4. Good? Graphed them both. Notice they are a reflection across the diagonal line, aren't they? See that? They always will be. Function in his inverse. All right, so y equals x cubed minus 8. Find the inverse function. Can you do that first off? So do those two steps. Switch x and y, solve for y. So switch x and y, solve for y. Good, I'll jump in. So you switch x and y, right? Switch or invert x and y, and now solve for y. So how do you solve for y? Jump the 8 to the other side. X plus 8 is y cubed. Good so far. Now how do you turn that into just plain regular y? What do you do? Cube root both sides, right? Because a cube root will cancel a third power, right? Roots are opposites of powers, aren't they? Good with that? So you cube root both sides. Oh, and by the way, you don't have to put plus or minus. You only put plus or minus for two roots, right? Because that's the whole plus minus thing. So we don't have to do that for cube roots. It's just like it is. Cube root of x plus 8. So there's the inverse function. It's the cube root of x plus 8. And that does look like the opposite of third power minus 8, doesn't it? So now they ask us, okay, find the inverse. I did, so that would go right here. Question B, state the domain and range of f. Okay. Yeah, okay. Yeah, let me help you with that. So, I'm going to go to a fresh screen and write the inverse here. Okay, so I have the let's start with the original function first. I have the original function, x cubed minus 8. Let's do his domain first off. I'll show you a nice way to do this. So what's the domain for that function? Everything, right? He's got no problem areas. You with me? He doesn't have any denominators. He doesn't have any roots. So domain, all reals. Everything's fine, no problems. Good? Now, what's the range of f? I have no idea right now. Remember, the only way we've gotten range up to this point has been by looking at a graph. So yeah, actually, if you could graph that, and I bet a lot of you can even picture the graph in your mind, then you know it goes, that's the snake, huh? That goes up and down forever. So really his range is all reals also. But let's pretend we don't even know the graph, because some of the ones we won't. Some of the ones will be hard. How could we find the range if we didn't even know what the graph looked like? What we could do now, here's the trick I want to show you. This is what they want you to see too. Is you go to the inverse function, which we just found, which was what? Cube root of x plus 8, right? That was the inverse we found. Go to him, and remember what we just said a few minutes ago about domain and range for the inverse function? The domain of the original is the range here, and the range of the original is the domain there. They switch roles. That's what an inverse function is, a trading of x's and y's, trading of inputs and outputs, range and domain. Right? So, what's my point in all that? Well, can I find the domain of this? Let's look at this right here and find domain. We can always do straight. Range, we need a graph. Okay, let me say that clearly. Are you with me? Am I doing the Charlie Brown? Wah, wah, wah. You're hearing these words.
I hear you.
Here's important words. Domain, we can do from a formula. Domain, we can do from formula. Range, we only get usually from a graph, right? The up and down on the graph. We haven't ever, up to this point, figured a way of finding range from the formula. We don't know. But we do domain straight from the formula. So my point is, do domain for this formula, and that automatically becomes the range for the inverse, right? The domain here becomes the range on that one, automatically. And then vice versa. Let's find the domain for this one using the formula, and that will automatically become the range of the original, won't it? See the game plan? So I can use the formula for both of them and trade those down to the ranges. So what's the domain of this one, looking at the formula? All reals. right? Remember, odd roots are not a problem. If that was an even root, a 2 root, I would say inside greater than or equal to 0. But it's an odd root. No problem. You put negatives in there. No problem. So this is also all reals. So in the end, this was just everything all reals. But you get the game plan? Find the domain for both the original and the inverse, and those trade and become the ranges for the others. That's how we do it. Questions? It's going to get a lot. 21. All right, so we got the original function, 4 over 6 plus x. So go ahead and find his inverse. Let's start with that, and then its domain and range for both. And it won't be all reals, will it? What's the domain of that one? The domain? X can't be 6, negative 6, right? Negative 6 would make that denominator 0. Anything else is fine. Anyway, but first find the inverse. So switch x and y, solve for y. Find the inverse function. Okay, so this is y, so switch x's and y's. I'll go over here and find the inverse. So this would be x equals 4 over 6 plus y. Good so far? I switched x and y. Now I'm going to find the inverse function over here. Right? I switch x and y. Did it? Okay, now solve for. Now, how do you solve that for y? I would cross multiply probably. Just put this over 1. Have you seen that before? Just make it look like a fraction. Diagonal, diagonal. Or you can just multiply both sides by 6 plus y. Maybe, yeah, I've been doing that. Maybe you'd prefer just to keep doing that. Whatever. It's going to be exactly the same either way. So you can just multiply both sides by the denominator. 6 plus y, 6 plus y. Cancels here. And then you get x times 6 plus y is 4. Good like that. Boom, boom. 6x plus, what am I doing here? 6x plus xy is 4. And what are we supposed to solve for? Y, right? Solve for y. Right? You switch x and y and solve for y. That's how you find an inverse. Switch x and y, solve for y. So how do we finish solving this thing for y? Move the 6x to the other side. Good to there. Last step. I'm going to do it slower here. Last step, divide by x. Boom. There it is. That's the inverse. And it kind of looks like the inverse of that one, doesn't it? It is. How are we doing? Is that good? That's the inverse. Hey, can I cancel these x's? No. Do you know I cannot? Why not? Why can't I cancel those x's? Glue. Right? Been talking about that, right? Pluses and minuses glue things together. If that minus wasn't there, then it'd be fine to cancel x's. But remember, plus and minuses glue things together. Which means if you want to cancel anything in that top, you go like that and cancel the entire top, or you take none of it. Right? It's Costco shopping. It's glued together. You buy the whole package, or you buy none of it. You can't just take part of it. Pluses and minuses glue things together. So we just leave it. So there's the inverse function. Okay, we good to there now? Now let's find the domain for both those and trade. It'll be the range for the opposite one. You guys tracking with me? How we doing? So come over here. Y equals 4 over 6 plus x. That's the original. Or I'll just call that f of x. Whatever. Either one's totally fine. And then over here, the inverse is 4 minus 6x. Okay, so we have those two. And so now domain here, we already said denominator cannot be 0. So 6 plus x cannot be 0. So x cannot be negative 6. That's the domain for that one. So what does that automatically become? The range for the inverse. X cannot be negative 6. It's the range for the inverse. Now let's come up here and find the domain of this one. What's the domain of the inverse? Yeah, denominator, I don't even care about the numerator at all, cannot be 0. That automatically becomes the range of the original. X cannot be 0. We're done. Got domain and range for both, original function and inverse. Is that good? That all making sense? So how do we find an inverse function? We switch x and y, solve for y. Once you got it, you put the original and the inverse side by side. You find the domain by the formula stuff we've learned. X cannot be, denominators can't be 0. Denominator can't be 0. And just trade. That's the range for the opposite one. Because that's what an inverse function does, is trade domains and ranges, x's and y's. That's why we switch x and y. Is it all making good sense?
I think the range, like, y cannot be minus.
Oh, you're right. It's supposed to be y. You're right. The range is supposed to be y, technically. Thank you. Range values are y values. Thank you. That's true.
And in the master cell, it said that y cannot equal to 0.
For the range here. Here, when we go back and for more. Let's see. Let's try that. This is just a little messier algebra, and this kind of gives people trouble sometimes. So let's try it. Y equals 8x over 9x minus 5. So find the inverse. So try that one. So you know what to do. Switch x and y, solve for y, right? Switch x and y, solve for y. So first step, switch or invert x and y. So that means both these trade, right? That one y becomes an x, and both x's become y's. Good so far? They literally trade rules. Everything else stays put. The 8, the 9, the 5, they're all right where they were. Nothing else moves, just x's, y's magically switch roles. That's what an inverse function is. Okay, now solve for y. That's a little harder. Solve for y, either cross multiply or multiply by the denominator, 9y minus 5. Solve for y there. All right, you're doing well. You okay? So multiply both sides by 9y minus 5. 9y minus 5. Boom. Cancels out. And we get over here 9y minus 5. X is 8y. 9xy minus 5x is 8y. Good so far? Now it gets a little tricky. How do you solve for that y? You see the problem? You might say, well, just divide by the 8. Well, no, it's here and it's here, huh? How do you solve for y in 2 spots? That's the trick. That's what I wanted to specifically help you with. I do like to put these on the test. So, you know me, no secrets. This is I don't remember exactly, but I bet. I'm sure. I always do. I always put one of these double y's because it's so valuable for calculus. This kind of thing you have to do in calculus all the time. So what do you do when the y is in 2 spots like that? You've got to, number 1, get the y's on the same side, and 2, factor out the y and divide. That's what you do. So get the 2 y's on the same side. Doesn't matter which side. So I'm just going to grab this whole 9xy term and jump it over here. That'll leave minus 5x is 8y minus 9xy. Good so far? So get the 2 terms that have y on the same side. Next step, so that was step 1. Next step, factor out that y. I don't care about factoring. If there's other numbers in common, I don't care. I'm just focused on the y. Factor out the y. like that. That's step 2. Factor out the y and then divide, Just divide by that 8 minus 9x. And that does it. See how that isolates the y? Real important skill for calculus. Lots of things like that all the time. So there it is. That is the inverse function. We solved for y. That's the inverse function. So then we'll do the domain and range real quick. Is that good so far? Questions on doing that? Okay, I will go to fresh screen if you guys got that down. So, one more time back there. So what the original was 8x. Okay, so the original function is y equals 8x over 9x minus 5. Then the inverse, minus 5x over 8 minus 9x. Minus 5x over 8 minus 9x. That's the inverse function. Minus 5 over 8 minus 9x. Yeah. Okay, so now we have these two. So now we're going to find domain and range on those. So how do we find domain and range? You know the deal. Let's find the domain over here first off. What's the domain on this one? Denominator not equal to 0. Jump it over. 9x is not 5. Divide by 9. X is not 5/9. What's the domain on the other one? Denominator 8 minus 9x not equal to 0. Jump it over. Minus 9x not equal to minus 8. Divide by minus 9. X not equal to 8/9. This becomes the range. This becomes the range. Good on all that? Questions? Everybody okay with all this solving back here? So it'll be on the YouTube later. Harder. Okay, so let me do some quick maybe. So y equals x squared minus 2. I just can't tell if there's something weird or not. So find the inverse. So you know the inverse. Invert x and y. So let's do that. Invert x, y. So this will become x. But what did I just do? I messed up, huh? This is y. Good to there? So they traded roles, x's and y's. How do I solve this equation now? Well, denominator. What do we always do with the denominator? Multiply both sides by that denominator. Boom. And so we get, what's that? 5. I'll just make it 5xy squared. This is y squared minus 2. Good to there so far? Now look at that. Y in 2 spots. What are you supposed to do when y is in 2 spots? Get the y's same side. Factor out y and divide, right? That's the game plan when y is in 2 spots. So get the 2 y's on the same side, factor out the y, and divide. So I'm going to grab this y squared and jump it here. 5xy squared minus y squared equals minus 2. Got the 2 y's on the same side. Factor out the y squared actually on this one, huh? 5x minus 1. And divide. Pretty much the same thing. Now that's y squared, so the last step is to root it, huh? You guys with me? Am I losing you? So we got y squared is minus 2 over 5x minus 1. Bring it up here. And last step then is going to be to throw a square root over that. Oh yeah, good job. Okay, they did a good job on. Okay, because normally I was just wondering. Normally when you put a square root, you're supposed to put plus or minus, right? You aware of that? You clear on that? right? If I have something like, just think with me for a second. If I have y squared equals 9, if I just root it and don't put plus or minus, you're only going to get 3. But negative 3 also squared is 9. Positive 3 and negative 3 are really both answers to the original question, when can y squared be 9, right? So when you put a square on a 2 root, not for a 3 root, odd roots, we don't have to do that. Because signs stay the same with odd powers, don't they? They don't change. But for even powers, you got to do the plus or minus, so you should get plus or minus 3. So my point in all that is right down here, shouldn't I put plus or minus? Yes and no. Y would be then plus or minus the square root of, this big mess. Kind of separate this here, like that. So y could be plus or minus. Now, that's the inverse function, right? We're saying the inverse is plus or minus square root of negative 2 over 5x minus 1, right? Because it's the inverse function. That's what we're finding. That's the y value, y equals. But notice what they said right here. X is only positive, right? X positive greater than 0. Well, you're talking about y over here, right? X on the original function is the same as y on the inverse function. So that means y on the inverse function is only positive. Only positive. That's how they got around the problem. You see that? They just specified. Anyway, don't worry. If you just want to ignore the plus minus thing, you'll always be fine on these inverse function ones. If I want to make life, and I do, I want to make life a little easier for you. Don't worry about all that plus or minus stuff. I mean, it's great if you can grab all that complexity that I just described. It is important later on. But it's not huge, and right now, just avoid the plus minus, you'll always be good on these inverse functions. They're always going to make them. So you don't have to look at this. You don't really have to look at this and worry about it, and you don't have to worry about the plus or minus. They're taking care of it. Just don't put plus or minus. It's all good. There's the inverse function. So he's got domain problems, right? I don't got time for that. So, whoops. I'm going to